Let's look at exact differential equations. The differential equation m of xy plus n of xy dy dx equals 0, where m sub y, and n sub x are continuous, is exact if m sub y equals n sub x. The general solution is f of xy equals c, where f sub x equals m and f sub y equals n. Sounds complicated, but you'll get it. You'll be fine. Often, we'll write this m of xy plus n of xy dy dx equals 0 as m of xy dx plus n of xy dy equals 0. So we're just multiplying both sides by dx. Verify that the differential equation 6y squared plus 6xy cubed plus 12 dx plus 9x squared y squared plus 12xy dy equals 0 is exact. We could have written this as 6y squared plus 6xy cubed plus 12 plus 9x squared y squared plus 12xy dy dx equals 0. So again, m is going to be 6y squared plus 6xy cubed plus 12. N is going to be 9x squared y squared plus 12xy. We want to verify that m sub y equals n sub x. That's the definition of exact. Okay, so m is going to be this. Take the derivative with respect to y, and you get 12y plus 18xy squared. N is this. Take the derivative with respect to x, and you get 18xy squared plus 12y. Oh, notice that these two are the same. M sub y equals n sub x. Therefore, it is an exact differential equation. Let's solve that differential equation. So we've seen that it's exact. Let's solve it. The general solution will be f of xy equals c, where f sub x equals m and f sub y equals n. That's why m sub y equals n sub x. It's because m sub y, well, since m is f sub x, m sub y is f sub xy, and in other words, f sub xy, and n sub x, well, since n is f sub y, n sub x is going to be f sub y sub x, in other words, f sub y x. And as we saw in Calculus 3, also called multivariate calculus, f sub xy equals f sub yx. So that's why m sub y is going to equal n sub x. Okay, so this is m, 6y cubed, or 6y squared, plus 6xy cubed plus 12, and that's going to be f sub x. N is 9x squared y squared plus 12xy, that's f sub y. Now we just need to integrate. So again, this is going to be our f sub x. Let's integrate both sides with respect to x. We get 6xy squared plus 6x squared y cubed over 2 plus 12x plus possibly some function y. Because when you take the derivative of this with respect to x, you're going to get this function. So there might be some function just of y running around in here. When we simplify that, we get 6xy squared plus 3x squared y cubed plus 12x plus that function of y. F sub y, on the other hand, is 9x squared y squared plus 12xy. Integrate with respect to y, and we get 9x squared y cubed over 3 plus 12xy squared over 2. In other words, it's 3x squared y cubed plus 6xy squared plus possibly some function of x, because when we differentiate this with respect to y, that function of x is just going to go away. Okay, so notice, wow, when we compare these two, check this out. So when we compare these two, they seem to be almost the same. So we got the 6xy squared, we got the 3x squared y cubed. Okay, this one has a 12x and this one doesn't, but that's okay because this function of x must be 12x. So it looks like, and this doesn't have any function of y in it, so it looks like this is going to work. So in this case, f is 6xy squared plus 3x squared y cubed plus 12x. So our general solution is going to be 6xy squared plus 3x squared y cubed plus 12x equals c. That's the general solution to this differential equation. We call 6xy squared plus 3x squared y cubed plus 12x equals c an implicit solution because we don't solve for y in terms of x. We just leave it alone.